So today we're doing 3.1. That's it. One little section. And chapter 3 is on numerical summary of data. And in particular, we're talking about measures of central tendency. Okay, so this question is kind of like what the measures of central tendency. This question asks, where is the center of the data? So I want you to recall our 4 major distributions that we talked about last week. And I'll redraw them here. 4 graphs. We could either have a hump on the left and a long tail on the right, or a hump on the right and a long tail on the left. We recall that the things on the bottom at the ends are called tails. So if one tail is longer than the other, we say that the data is skewed in that direction. So the tail over here is longer on the right. We call this skewed right. On the one on the lower left, it's longer on the left. We call this one skewed left. Then we had one that's kind of like flat, might be little ripples in it. Some areas might be taller than the rest, but not by a lot. This was called the uniform distribution. Everything's just about the same. This is just like, it's a meh. You look at it, you go, meh. It's a fucking lame graph. Everything's about the same. And then we have the graph where both tails are about of the same length. And we call this the bell-shaped distribution. And it's also known as the normal distribution. And bell shapes come in different ways. I mean, I could have a tall, slender one like this. I could have a flatter one where the tails are a little higher up, but it's still mounted in the middle. I could have one that's where it's really low and it just kind of spikes in the middle. And presumably, if I had drawn that well, all the centers of the humps would be in the same spot, but they're not, because I'm not an artist. But there's like, so humps the bell shape can be tall and narrow. It can be short and wide. It can be average. And we'll look at that one more first. Maybe I'll do it a little bit better justice if I draw it bigger. And then maybe, let's see, I want the top to be right here. The point is it's got this hump in the middle. And so for bell-shaped, this is our center. Center of the hump. And for bell-shaped, that is the mean. Distribution is going to be kind of the same way. For the uniform distribution, we'll also say the mean. This isn't the most exciting stuff. Not a lot going on yet. We haven't even done any math with this stuff. We will. We're getting there. It just so happens that the median is in the same spot as well. The mean is going to equal the median. And it's also usually the mode. And I haven't explained how to calculate any of those yet, but we will.
So would they have like the same value or?
Yes, if they're the same, it'll be the same value.
So the mean and median,
Yes.
okay.
And when we have actual numbers, I'll show it to you. Or if they're not the same value, they're really, really fucking close. Like 21.1 and 21.2 or something like that. Oh, I get to teach Sandy's kid young how to cuss. Yeah. All right, then let's look at our other graph. I'll just do one of them per now on this page. So this is my skewed right picture. In the middle of the hump right here, If I actually like look at it and go, okay, if I look at the center of the hump, the stuff to the left of it, the stuff I'm shading red right now, does that look like it's about the same amount of area as if I shaded the shit on the right? No, it doesn't, right? Like if I shade this over here green, doesn't look like the green's got a lot more space. It does. So the hump is no good. Hump doesn't work for center on skewed graph. In fact, the hump isn't even going to be the mean. Now let's picture where this would be. I'm gonna like to get an idea. of how this looks. Pretend this is a graph of like income. Household income. And fucking Elon Musk is in this room. So Elon Musk is going to be way off the page. Like I can't show you how far off the page he is because he makes so many more digits than we do, just like zeros after the number place. But if we want to take the mean, which is an average, if we talked about the average income in this room with Elon Musk in here, it would say that we are all millionaires, that we make millions. And that's not true for any one of us except Elon Musk. So, but with that in mind, if we took like the middle value, if everybody just listed their numbers, like how much I make, how much you make, how much you make, and we just like put them in order and then went for the center, that's the median, that's probably going to be closer to everyone's income except Elon Musk. Right? So if we took anyone's income in this room, right now, it'd be closer to the average income than Elon Musk. So what that does is the mean is generally much further to the right in the direction of the skew than the median is. And as I was saying, if Elon Musk is in here, mean is average. We can't use the average income as any reasonable measure of anything in this room with someone like Elon Musk in here. Like the average income doesn't reflect a goddamn thing about most of the people in this room. So we don't want to really use mean. We want to focus on the median as our center. So since these are off of histograms and numbers to the left are lower to the numbers to the right, this means that the median is less than the mean for skewed right. The way to remember it is the mean is further along the tail. It's further towards the end of the tail. So here, like this one, the mean might be over here. That's probably not that far to the left. I'm over exaggerating it. But the median will be to the right of it, which means the median is greater than the mean. Or mean is less than median. So for skewed graphs, we'll use the center. And for bell-shaped or uniform, we'll use the mean. On skewed or on bell-shaped graph, the mean is right next to the median. So we might as well use, say, the median on all of them. But in all reality, getting the mean is much easier to work with, and it tends to be more reflective. So we're going to use the mean. Okay, so what does all this mean? What's a good question will be? Maybe I'll just use the data I have in the set. I'm trying to ask a question, think of a question that'll be good, that's bell shaped. We'll try it. Does anyone in here have a lot of brothers and sisters? How many?
Well, there's 7.
There's a lot.
Me, 8.
Oh, yeah. All right, I don't want to use that one. We'll use data for it. All right, so mean, what is the mean? The mean is the average. What we do is we add up all the values. That's step 1. Step 2 is divide by the number of values there were. So I'm going to do the siblings. Well, I'll only use a couple people as an example. I have one sibling. Erlinda, is that it? Erlinda has 7. Anyone else want to volunteer their siblings? You got 2, that'll work. That's good. We'll stop there. So finding the mean is what we do is we take those, we add them up. In this case, we get 10. That's step 1. Step 2 is divide that number by the total number of entries. There were 3 people that answered this question, myself included. So I will divide by 3. And on a calculator, I'm going to get 3.33, and that's 3 is repeating. If you do this on a calculator, you want to do it this way. There's 2 options you really have. And adding and hit equal. Then divide. Or if your calculator has a parentheses key, you can use the parentheses key and do 1 plus 7 plus 2, hit the end parentheses, and then do the divide by 3, and then hit the equal key. And you can do it all at once that way. If it doesn't have a parentheses, you kind of want to hit enter after you do all the adding. So if you need to do it by hand, and there will be like a couple things in class where you will, like on the exam, I'll have you do the mean, but it'll only have like 5 numbers on it, not like something big. Most of the time, you're going to use software to do it, and I will show you how to do it on software. But you should know how it works. For small things, small amount of numbers, it's quicker just to put it in your calculator than it is to try to pull out a computer and do it on software. Much quicker. That's how we find the mean. The mean has a couple symbols. The symbols that we use for the mean. We have this one, and we have this one. And I am really over exaggerating that tail on the left on the U, because it looks like the letter U, but with a really long tail. It is not the letter U, it is actually the Greek character mu. And if you like Pokemon, it's like Mewtwo, Mew, that kind of Mew. We call this one X-bar. And this is true for all of the variables we will use in this class. Variables with English letters. Characters are for a sample group. The ones we'll see in this class for that. X bar, S, and S squared. Characters that are Greek, mu is a Greek character. Greek characters are for the population. So here we have mu and sigma squared. So mu and sigma. And these are the lowercase letters. And I said, when we said add up everything and divide by the total number of entries, when we're talking about it in statistics, the total entries for a sample we give the lowercase n. And this is the only time that we use an English character for population. The total entries for a population we use capital N. That's the only exception to that Greek rule. And I'm going to use something you may not like, but you don't really need to use it long, but it's important that you know what it is when you see it. So we just had for siblings, we had 1, 7, and 2. They will use X and this lowercase number to indicate which person it is. So the X sub 1 number, that was my response. The X sub 2 number was her response. And X sub 3 number was your response. So if there's a lot of them, they will say X sub I for the I person's response. And when they do, where you might see that, they'll put it in this notation. They will have an E that looks very angular like this. And it will say X sub I like that all over N. That equals X bar. This crazy looking E up here, that really looks like a capital M sideways. This is the uppercase sigma. And it means sum. Yep. And it means sum, add it up. Sum or add. So the uppercase sigma says add up all the xi's or add up all the entries and divide by n. If you've used Microsoft Excel, and I imagine Google Sheets has it too. This is that symbol sigma shows up on there too. You may not have known it was called sigma, but it is. And it has the same purpose. It's sum on there also. Let's take a look at how we calculate median real quick. And let me get a couple more people's siblings. Let's see some more siblings. So we had 1, 7, and 2. Do we got any more entries? Anybody want to say how many you got? You got 8? Holy crap, there's 2 of you with large numbers. It's no longer an outlier. Anybody else? 2? 5. We'll do that. All right, so median. Them in order. Step 1, step A, sort them in increasing order. So I see a 1, I see a 2, there's another 2, I have a 5, I have a 7, and I have an 8. Now B, go inward one at a time until you get to the middle. From each side. And 2 scenarios arise from this. Either there is 1 number in the middle. And that will be your mean. Or median. If there's 2 numbers in the middle, we take the average of them. Which is like doing X plus Y over 2. So let's take a look at how that works on what we got here for ours. I want to make sure everyone has a chance to write this stuff down. So if I do that here, I'm gonna work in one at a time. I go in one there and I go in one there. And then I'll go another one in on the left and I'll go another one out in on the left. And if I do that again, my arrows are gonna touch, which means there's 2 in the middle. So the median for that set will be 2 plus 5 over 2. That ends up being 3.5. If I do the mean on this same set of data, I've got 1 plus 2 plus 2 plus 5 plus 7 plus 8 over 6. That's going to give me 25 over 6, which is like 4.167. Notice that the mean and the median are different. This is usually the case. They're usually not spot on, but they're usually pretty close. Okay, a little bit more terminology. The mode. I mentioned mean and median, and I said mode. Mode is the response with the most answers. Or entries. In our data set that we had up there, just 6 numbers. Two showed up twice. And every other number showed up once. So the mode for this group is 2. And it just happens, it's a coincidence that it showed up twice and it was the number 2. If there was like, let me maybe add another 2 and another 2 like that to make it clear that it's the value that it's the mode, not the number of them. So like here, I've got 4 2s, so the mode is 2. It's the most common entry. If all responses are unique, we say there's no mode. I'm getting a bigger and bigger neutral zone here. It's like the wasteland up front. Where's Hansel? If there's 2 responses with the same count, it's called bimodal. And when we have that, the graph will look something like this. There will be a hump in one spot and there will be another hump at the exact same height. The humps might be right next to each other, so it looks like one hump. Like if it was just 2 and 3 were the answers, they're really close to each other in terms of siblings. So you wouldn't be able to distinguish them from each other. But generally, it means if you see 2 like that, it's going to be bimodal. And then if they have more than 2, they stop coming up with good names. They just call it multimodal. And there's one really good example of when we use mode. Because I told you we used mean and median a lot. There's one really good reason to use mode. It's a phenomenal reason. If I took a survey of everyone's hair color in this room, and I've got like black, brown, black, where's Bernice? Red. How do I find the mean of hair color? I can't. The mean and the median require numbers. So if the data is categorical data, not or qualitative data, means that the mean and median can't be found. Couple of more terminology words, and I'll show you how to do this stuff in StatCrunch. We'll be done in like 10 or 15 minutes. Then you'll be free to either leave or work on homework here if you so choose. Some people are still writing though. I don't want to rush anybody, so. I've been twitching without my phone.
Oh, I thought you ended up going to get it.
No, I wanted to. It would be the one day that I don't get people coming by office hours very often. I usually just work. I was grading computer science homework earlier. But if I miss it for like one day, I'm going to get up an email and go, I stopped by your office, but you weren't there. You know how that works. You know, one day. Everyone ready? All right. Related to the Elon Musks of the world. Things like that. When we have a set of data, and one or more entries is just way outside the normal region. We call them outliers. Now, in a room full of students. Elon Musk is an outlier for income. In a room with the CEOs with the Fortune 500, room full of Fortune 500 CEOs. Probably isn't, he might still be, but we would be an outlier. So it doesn't have to be a number that's much larger than all the rest. It can also be much lower than the rest. I'm pretty happy with my income, but if I get into a room with Fortune 500 people, I'm gonna fucking feel like a broke ass bitch. They're all talking about their yachts and shit, and I'm like, I got a yacht. It's made of paper. I fucking, float that motherfucker. I waxed it so it floats better. I got a plane. Here, let me show you. I'll make it for you. So it can be something that's really low, a lot lower than everything else, or something that's a lot higher than everybody else. When you're talking about smart people, like geniuses, they are outliers. Most people are within a certain range around average intelligence. Some are higher, some are lower, but most people are in a certain range. There are some people that are just geniuses that are just off the end on one side. There are also people that, make a tree stump look intelligent. They can't put two things together. They're just not, they don't have it there. But they're very rare to find anyone that's really like that. It's easy to find people that are above intelligence, below intelligence, a range of it. But people that are like, you talk to them and you're like, oh my God, I feel like a dumb shit. Like, if you watch Criminal Minds, my wife's got me watching this. Like Dr. Reed's a genius. He's like, he can read 600 pages in like a night or like an hour or something like that and memorize everything. Quick divergence while that's in my head. We were watching that last night, and the guy that plays the boss on Criminal Minds, his name's Gideon. We're like on episode like 11 of the first season. She's watched them all, but I haven't, so she's making me watch them. And I'm listening to it, and I keep listening to it, and I'm going, his voice sounds so fucking familiar. It's just like it's soothing to listen to his voice. It makes me think of my childhood. I had no fucking idea why. And I finally looked up his name. His name's Mandy Patinkin. And I looked up, what role is he most famous for? If you've seen Princess Bride, he's Inigo Montoya. He's the guy that's on a quest to kill the guy that killed his father. My name is Inigo Montoya. You killed my father. Prepare to die. He fucking says that line a lot. He's a good guy in the show, but for a while, he just seems like a murderer. He's out to murder someone. But that's him. And I'm like, there's no way I would have ever fucking guessed it. All right, back to work. So outliers. What do outliers do to our numbers? Like our mean and our median. I think with the Elon Musk one, I think you can kind of tell we're talking about income and you thought about average income and we just redistributed his wealth to all of us. And how we'd all be fucking super wealthy. The mean is affected by outliers. Now, the median one, it might be a little bit easier if I talk about the siblings thing. We had one, we had a couple twos, we had a 5, a 7, and 8. What if we had someone in here, just one person, that had like 20 fucking siblings? It's possible. Dad could be, getting around town, and it doesn't have to necessarily be mean, same mom. Got a lot of siblings, but if we're looking at the middle, we put them in the order. That person with the 20 siblings is on the end and is nowhere near to the middle, so it doesn't hardly affect the middle at all. The median is unaffected. They have a word for this. When something is unaffected by outliers, they say it is resistant. The median is resistant to change, basically. The mean is not. We only got a few more things to write. I'm going to give you the written instructions for finding this stuff in StatCrunch. Then I'm going to show you. Some people like having that written list, so I think it's worth showing a written list. So how do we find this stuff in StatCrunch? We are going to click on stats, the drop-down menu for stats. Then we'll click on summary stats. And then columns. We as a people tend to sort entries as rows. So like if we want the mean of something, it's all in one column. Once you're on that menu, you want to select the columns that you want. And then in a box called the stats box, select the summary statistics you want. Finally, click compute. These are called summary statistics because they summarize the data. If I can just talk about this group's income and just use the mean, the average income in here is so-and-so. It's summarizing all of our income into just one number. I'll leave that up there for you guys for a little bit to write down, and I'll switch cameras over and we'll look at a data set. You guys ready? So here's my data set that we've been using from the survey. And I'm gonna follow the instructions I gave you. I'm gonna go to stats right here. Then we're gonna go to summary stats. And we're gonna choose columns. And it only will allow us to choose columns that have numbers in them. Unfortunately, it won't let us choose columns that have other category or other things. Because it doesn't want you trying to calculate the mean or the median or anything like that on like hair color. So let's say I want to take a look at age and maybe height. I have a list of statistics I can choose from in this statistics box. And tells me the number of entries. There's mean, which is what we were talking about. There's median. And mode is way down at the bottom. If you want to click things that are not connected to each other, I think we talked about this last time, hold down Control and then click on the next thing. But I can see over here on the right what I have selected. Mean, median, and mode. And I can click compute. So it's telling me the average age of my people are 26.6. The median is 21. And the mode is 18. I have a histogram of these as well. Actually, I'm going to edit this. I'm going to add in markers for mean and median. This helps. So this first graph is the age graph, and the green line is the median, and the green line is the mean, the red line is the median. Notice that the mean is larger than the median, and we can see that on this graph. The green is further to the right than the red. The mode is 18-year-olds. 18-year-olds are the most common entry for a college-age student. And as we go to the right, we taper off. This person over here is an outlier. I think that person's 79, I think they put. We might even include the one that's like over here. So this one has outliers on it. If we look at the height. Oh, the height's going the other way. This is screwed up because people put in that they were 5.6 inches tall rather than 5 feet 6 inches tall. Maybe let's not do height. Let me edit this to do shoe size instead. So on the shoe size, we got the mean is 8.98 and the median and the mode are 9. 8.98 is pretty fucking close to 9, right? And you'll notice that the graph is kind of like a bell. You know, there's a bunch in the middle. There's very few on the outside edges. So on the bell shape, we can see the mean and the median are near each other. The green and the red line are near each other. On the other picture, with the age, we're skewed and they're not touching each other. And this is how you find them. Now, it comes with a lot of default things when you click it. If we go stats, summary stats, columns, and I just click on age, there's a lot of stuff over here that is selected. I'm going to click compute. there's a lot of stuff there that's selected. We'll end up using pretty soon, the min, the max, the Q1, the Q3, the range. And standard deviation, all of those are standard things that we're going to be using soon. And it kind of like default selects all of those for you. So if you just skip the picking of the stuff you want, you're going to generally get what you need anyways. Like I didn't have to go through this box right here. I didn't have to go through this box and pick a bunch when it picks already a bunch of good ones already. Okay. You are now free to roam about the country, or if you want to work on homework in here, you can. Whatever works for you.
I have a
Any
question.
questions? I was about to ask, any questions at home? Go for it, Desiree.
So like all this vocabulary and stuff that we're doing are we gonna be tested on this as well?
I test you on like what is resistant. I'm not going to ask you to give me a definition, but I might ask you what is resistant. Resistant is important.
Okay,
Mean and median, I'm not going to ask you to give me a definition, but you kind of need to know what they are.
okay,
Because they're like the driving things in statistics. The mean and the median are the most important things in it. So I won't ask you like to write a definition, but I will ask you, what is the mean for this set of data? What is the median? And you have to be able to get it.
okay.
Okay?
Yep, thank you.
Huh? Have a nice night, Keelan. I will do stop record.